Welcome, trig students. Today I want to tell you a little bit about what you're going to be working on. So today you're going to be practicing using some new trig identities. So we'll talk in more detail when we get back about this, but for today you guys will be using reciprocal, quotient, and Pythagorean identities to do some delta maths. So the reciprocal identities and the quotient identities you can use as is. The Pythagoreans you can rearrange. So for example, if I could add or subtract things from both sides. So if I look at P3, it says tan squared theta plus 1 is equal to secant squared theta. I could subtract 1 from both sides and say that tan squared is equal to 1 minus secant squared theta. And you might need to do that kind of thing to manipulate the Pythagoreans by adding or subtracting things from both sides to do some of the problems here in the delta math. So let's take a look and kind of show you how we'll use these things. So we have here that secant squared minus tangent squared over cosecant squared is equivalent to, well, so I'm going to work on the top first because this looks like a Pythagorean where I have things added or subtracted from one another. I go over and look at P3, that involves both tangent squared and secant squared. If I subtract tangent squared from both sides, I'm going to have 1 is equal to secant squared minus tangent squared. That's exactly what I have in the top. So I know this numerator can just be rewritten as 1. Now I have 1 over something. When I have 1 over something, I'm going to go look at the reciprocals. And I see that 1 over cosecant is sine. But I have 1 over cosecant squared. So that's going to be 1 over, or is going to be, 1 over cosecant squared is going to be sine squared. So I'm going to pick that and hit submit. Here I have 10 minus 10 cotangent squared theta. So when I look at this, I'm going to factor out a negative 10 because I see that's in common to both pieces. If I do that, I'm going to have 1 plus cotangent squared. That's, again, when I see addition subtraction, I'm going to look at the Pythagoreans. 1 plus cotangent squared is cosecant squared. So I'm going to have that negative 10 that I factored to the front times cosecant squared. That's one of my options. So I'll hit submit. Look at what I have here. So I'm going to start with the bottom where I see 2 things added or subtracted. Again, I'm looking for those added and subtracted. This is typically my place I want to start first. And since I see sine squared, I'm going to be looking at P1, the Pythagoreans. And I notice if I subtract sine squared from both sides, I'm left with cosine squared equals 1 and then minus sine squared. So I know that I can replace 1 minus sine squared with cosine squared. So I have negative cosine squared over cosine squared. Well, the cosine squared is going to reduce to 1, so you're left with negative 1. And I hope at this point we kind of get the idea. Let's try another one. So this is the same idea, but in this case we've removed the multiple choice option. So again, I'm going to start where I see the addition and subtraction. That's going to be a Pythagorean. So I notice that, hey, P1 has cosines in it. If I subtract cosine squared from both sides, I'd have sine squared equals 1 and then minus cosine squared. So that's my top of my fraction. So I know that this is equal to sine squared. And sine squared over sine squared is just going to be 1. Okay, so it's the same process as the previous ones, but you've lost the multiple choice. If I look at the last one, this is reciprocal identities, so we're going to be using the reciprocal ones. The quotients I would count inside of that. So if I have cotangent squared times sine squared, I'm going to look at my cotangent identities. So I'm going to look at the reciprocal one, and I'm going to pick the one that has a sign in it because there's a sign in the problem. So cotangent is cosine over sine. So cotangent squared is going to be cosine squared over sine squared. So if I take that and I replace the cotangent squared, I'm going to have cosine squared over sine squared times sine squared over 1. I can reduce the sine squared, so I'm left with just cosine squared. And don't forget to put your variable in there. Try another one. So here I have tangent squared over secant squared. So I would start by thinking about this as tangent squared times 1 over secant squared, right? So I'm going to think about tangent squared times 1 over secant squared. Now I'm going to replace tangent squared with one of the quotient identities. So if I look at my two options, this one I like because it has secants in the numerator, and I have 1 over secant squared. So that seems like a good choice to me. So that's going to give me, since I have tan squared here, I'm going to have tan squared equals secant squared over cosecant squared. And if I go to my problem, I'd have secant squared over cosecant squared times 1 over secant squared. The secants are going to cross out, so I'd have 1 over cosecant squared. Now when I have 1 over something, that's going to be a reciprocal identity. So let's go look at my reciprocal identities. I'm looking for 1 over cosecants. I see that right away. Now I know 1 over cosecant is sine from here, but I have 1 over cosecant squared, so that's going to be sine squared. And then if I do like shift in the number 6, that'll give me my exponent. Make sure I move out of the exponent to press my theta, and then press enter, and I just continue on. Do your best with these guys. We'll talk more about it when we get to class on Tuesday. Okay? Have a good rest of your day off. Good luck with your problems. Do the best you can. If you're having a hard time, we'll do some more examples in class on Tuesday. Bye-bye. Bye-bye.